Okay, welcome. Today we're going to talk about graphing higher degree polynomials, and this is part one. So go ahead and take your notes out and we'll get going. Remember, during the video, if you should fall behind or not quite understand something, stop the video, rewind it, and listen to it again, and get your notes caught back up. Sometimes it takes a couple times through to understand the concept. Okay, let's go ahead and begin. So today we're going to talk about graphing polynomials that aren't quadratics. We learned a lot of techniques in graphing quadratics. So today we're going to look at what happens if the degree is higher than 2. How do we graph these? Okay, so the first thing we have to remember is recall the leading coefficient test. We refer to these as the M behaviors. What's going on with the graph at the very ends? So we're going to look at our polynomial. So if we have f of x, and it's all about the leading term. We're going to look at the power, and we're going to look at the coefficient. The first thing we'll look at is the power. What happens if the power was odd? When n is odd, our exponent is odd. Well, when n is odd and the leading coefficient is positive, we can say the n behaviors are looking like this. And what that means is as x goes to negative infinity, the left side of the graph as I call it, the graph is heading down. It's heading down to negative infinity at the very, very end. As x goes to positive infinity, the graph is heading up. It's heading up to positive infinity in the y direction. Now, if I were to flip that, if I said, what happens if a is negative? Well, a is negative, it's going to reverse. Sorry, as x goes to negative infinity, our graph goes from heading down to heading up. It's just flipped. As x goes to positive infinity, what was heading up is now heading down. In terms of translations, a negative a simply means I'm reflecting it across the x-axis. So things are going to flip. All right, let's look what happens when n is positive. N is positive. Okay, so when our exponent is, and I said positive, sorry, when n is even, when our exponent is even, both our n behaviors are going the same direction, So when n is even and the leading coefficient is positive, so let's make sure we get that straight. Our exponent is even, leading coefficient is positive, both n behaviors are heading up towards infinity. When the leading coefficient is negative, think of translations, it's a reflection, the graph will flip. Both our n behaviors are heading down to negative infinity. Okay, so as we head into graphing, the way we're going to graph is we're going to first find the zeros of the function, plot those, and then use n behaviors, and from there, connect the dots and get it just a rough sketch. It won't be perfect. We got calculators for that, but it'll give us a rough idea of what this is going to look like. So let's go ahead and try one. Okay, our first polynomial function is f of x is equal to 2x to the fourth minus 8x squared. Okay, the first thing I'm going to do is find the zeros. So step number one, let's find zeros. And as I look at this function, I can see that this appears to be factorable. So the first thing I'm going to do is set y equal to 0 and factor this guy. Okay, so as I find the zeros, or x-intercepts, or what is x when y is 0, I'm looking for factoring. That's always my first step, because factoring is quick and easy. And I notice right away they have a greatest common factor, a GCF of x squared. And that will leave me inside the parentheses an x squared minus 4. Okay, to factor further, I can see this is a difference of squares. So I can see that I have 2x squared times x plus 2 and x minus 2. Okay, now we're factored. So I have three factors. When multiplied together equals 0, according to the zero product property. My solutions are when each one will equal 0. So I'll set each factor equal to 0 and solve. Each factor equal to 0 and solve. Now these last two factors we can actually see in our head. We can see that's going to be negative 2, because we're going to subtract 2 from both sides. And this one is, sorry about that, is going to be positive 2. I'm going to add 2 to both sides. So I'll quickly throw those solutions down. That's going to be positive 2 plus 2 plus 2. And again, my pen is acting up, So let's kind of take this out and let's rewrite this whole thing. So I'll have x minus 2 is equal to 0. So this solution will be, or 0 will be, x is 2 by adding 2 to both sides. This one will be subtracting 2 from both sides, gives me x is negative 2. I've got two zeros. This is the one we kind of want to focus on. Okay, solving for 0 will be dividing by 2. 0 divided by 2 is still 0. I'm going to square both sides, and I get x is 0. Okay, now we have three zeros, 0, negative 2, and 2. But if I look at my power, we know by the fundamental theorem of algebra that corollary, we have 4 possible answers. Okay, but I'm showing 3. And the key is my exponent right here. Okay, we say this has a multiplicity of 2, which implies I actually have 2 answers at 0. Okay, so my answers are really 0 and 0, 2 of the same answers. Okay, and that's going to affect how we graph, so we got to make a note of that. So I'm going to put a little star by this one. Okay, so as I go plot my points, here I go. I'm going to plot 2, negative 2, and 1 at 0. Now my M behaviors, my leading coefficient is 2, and he's positive. It's even, so I'm going to write even up here, which means both my M behaviors are heading towards infinity. They're both going the same way. So I have an M behavior heading this way, and one heading up this way over here somewhere. So knowing my zeros and my M behaviors, I'm simply going to come down and sketch the graph. Now I got to make note of, I have a double root, we call it, at 0. And with a double root, it means we're simply going to bounce off the graph. We're going to touch it. It's a point of tangency. And the other points we simply go through. So I'm going to come down this way through negative 2 or positive 2. Don't know how far it's going to go down, but down there somewhere it's going to come back up. Now because again the double root, multiplicity of 2 over there, we're going to bounce or just touch it at a point of tangency, come back down through negative 2 and head this way. And there's a graph of our polynomial function. It is a rough sketch. Remember, these areas can go pretty far down or maybe just barely crossing. We don't know without actually plugging in more points. But again, we're just after a rough sketch. So the key was this, was factoring, identifying your zeros. Pay close attention to the double root, because at any double root, anytime you have 2 of the same answer, the graph just touches the x-axis. I like to say bouncing off it. Doesn't go through it. If it's not a double root, the graph has to go through it. And one last thing, the graph can only cross the x-axis at the points you find. Okay, I hope that helps a little bit. Go ahead and make sure you have your notes ready for class. If you have anything else you didn't quite understand, make sure you jot it down on the side or any questions, and we'll handle them during class. Thank you.